Okay, now we are looking at the resource allocation graph. Resource allocation graph will describe the deadlock in a more precise manner. And this graph consists of a set of vertices V and a set of edges E. Okay, so in the V, there are two types. One is denoted by P, which is the process, and R are the resource types. And then it has two edges, the request edge and the assignment edge. Okay, so for these edges, you need to actually look at the arrowhead carefully. Okay, so the request edge is the directed edge from the process to resource. Okay, so when process is pointing to the resource, meaning that the process is requesting the resource. Okay, and the other one is the assignment edge. Okay, so if you look at the assignment edge, and you can see that now resource is pointing towards the process. So it tells that this resource belongs to the process. Okay, so look carefully at the arrowhead to see whether it is a request edge or whether it is an assignment edge. It's very important. Okay, resource allocation graph has few elements. So process will be denoted by the circles and resource will be denoted by the squares. And if you see there are small squares within that square, okay, it tells that this resources has instances. The number of squares or dot inside that square tells how many instances the resource has. For example, in this diagram, so this resource has 4 instances. Okay, and this to denote the relationship between the process and the resource. Look at the arrowhead here. So now we have P and the arrowhead is pointing towards the resource. It tells that this process requests to have the resource. Okay, and then the other one is P is holding an instance. Okay, P is holding an instance. And again, look at the arrowhead, so you can see that now the resource is pointing towards the P. So meaning that P is holding the resource. Okay, so this is an example of a resource allocation graph. So from here you can see the relationship between the process and the resource. Okay, so as I said earlier, if we have P is pointing towards the R, P1 is pointing towards the R1, is telling that P1 requests to have the resource 1. Okay, but R1 is pointing towards P2. It tells that R1, okay, is now owned by process 2. Okay, so if you look at this diagram, also you can see that R2 has 2 instances. R2 has 2 instances. One is holding by P1, while the other one is holding by P2. Okay, and from here also you can see that P2 now is requesting R3. However, R3 belongs to P3. Okay, so this is how you read the resource allocation graph. Okay, next we have another graph, and this time there is a cycle but no deadlock. Okay, so if you look at here, so we have P1, R1, P3, R2, P1. So there is a cycle here. However, it is not considered as a deadlock because if you look at resource 1 and resource 2, both resources has 2 instances. Okay, so for R1, one of the resources belongs to P2, which is not within the circle, which within the cycle. So therefore, it is not considered as a deadlock. The same goes with resource 2. It has two instances, and one instance is owned by P4, which is not part of the circle. So it is not a deadlock. So the basic facts that you must understand about the resource allocation graph is that if a graph contains no cycle, there is no deadlock. But if a graph contains a cycle, then you must check. If there is only one instance, then there is a deadlock. But if there are several instances within that cycle, there is a possibility of a deadlock, but it is not definite. Okay, so this is how we read the resource allocation graph to determine whether there is a deadlock or no deadlock in the model.